Welcome to you from OG Benchmarks. Let's talk about a little bit of benchmarking. This video covers two Xeon CPUs, the X3440 and X3450. This video also touches upon the exciting topic of thermal throttling. As I said, this video covers the Xeon X3440 and X3450. These are the weakest 4-core 8-thread CPUs in the Nehalem lineup. But hey, they're still 4-core 8-thread. As Xeons, these are server CPUs, but there isn't much difference between the desktop and server CPUs at this stage of Intel's lineup. I know that 4 cores, 4 threads isn't very impressive these days with 8 and even 10-core CPUs generally available. Back in the day of Intel's first generation, however, these were really nice processors. Another trait of these early CPUs is that they also took a lot of power. 95 watts. Of course, older CPUs are always going to be less efficient than new ones. For full disclosure, here is the parts list for these benchmarks. The motherboard is an Intel with an H55 chipset. That's an LGA 1156 socket. I'm using the Intel stock cooler, 8 gigabytes of DDR3-1333 RAM, 650 watt power supply, and an Asus GT240 GPU, because these Xeons do not have an integrated GPU for video out. And I have a 240 gigabyte SSD with Windows, Cinebench R23, hardware monitor, and Speccy. More full disclosure, here's how I run the benchmarks. I run through a single core benchmark. That's the full benchmark with a 10-minute run. I watch the temps, clock speeds, and power levels to make sure there are no thermal problems. I then repeat with the multi-core benchmarks. I then shut down all the apps and Wi-Fi, let everything cool, and then run both benchmarks to get the scores. I'm no expert in benchmarking, but this approach seems to work all right. Note that I think it's important to shut down all the possible background applications to let the CPU focus on the benchmark processes. I pretty quickly ran into a problem with the X3440. The single core benchmark was fine, but the CPU was throttling during the multi-core process. Instead of hitting the full turbo at 2.66 gigahertz, speeds were spending time down at 2.53 gigahertz periodically. Likewise, the power was alternating between 110 watts and 95 watts. So 110 is the turbo and 95 is the base power. Temperatures were reaching upwards of 80 degrees. The CPU is getting too hot. The benchmark still runs, of course, but I want to see the CPU perform at its best. Thermal throttling is not a surprise because I'm just using the stock Intel cooler on my test bench. I'm not sure, but I think the old Intel stock cooler is only rated at 65 watts TDP on the CPU. The Nehalem CPUs are well over that figure. Furthermore, there are different Intel stock coolers, and I'm using the weaker one with an all-aluminum heatsink. The one with a copper core is supposedly a little bit better. To fix this problem, I picked up a better cooler, the CoolerMaster Hyper 212 Black Edition. This was about $35 on Amazon when I bought it. Now that I've gotten around to recording this video, the price is closer to $45, but these prices bounce around quite a bit. CoolerMaster has several Hyper 212 models, and I think they all perform similarly. CoolerMaster does not give a max CPU TDP for this cooler, but people online say it could handle a 150 watt CPU. That sounds kind of high to me, but it's certainly way better than the stock Intel cooler. By the way, these stupid fan clips really annoy me. I guess they work, but I use them incorrectly way more often than I actually get them right. With a better cooler, the benchmarks went without a hitch. CPU temps were in the 60 to 65 degree range during benchmarking, and power levels were constant at about 110 watts. The Xeon X3440 gave scores of 464 and 2242 for the single and multi-core scores respectively. With the Intel cooler, the numbers were 461 and 2186. The single core score is essentially the same because the CPU wasn't getting too hot during those runs with the Intel cooler. The multi-core score is a bit higher with the Hyper 212. Thermal throttling doesn't crush the benchmark score. It just pushes it down as the CPU slows a bit to keep temperatures under control. The X3450 performs somewhat better with scores of 501 for the single core and 2341 on the multi-core. I started doing these price performance graphs in my previous video, and I want to keep adding to them. On the y-axis is performance based on Cinebench score. The blue dots are for the single core and orange dots are multi-core. The i5 CPUs in X3440 are 4-core, 4-thread, no hyper-threading. On the x-axis is the bulk MSRP as listed on Wikipedia on the Nehalem microarchitecture page. Single core is a bit irrelevant, but the multi-core points show that the X3440 was maybe a pretty good deal back in the day at MSRP. Its performance was better than the non-hyper-threaded chips without the premium price of the X3450. That was then. How do these CPUs stack up based on today's prices? Here is a price performance plot based on the prices I paid on eBay for these CPUs. These prices include tax and shipping. It's a bit harder to compare these points because if you bought these CPUs 10 times on eBay, you get a bit of a spread in prices. You can see this in the X3440 and X3450. The market doesn't really distinguish these CPUs, and I actually found the better CPU, the X3450, at a slightly lower price. The MSRP values, while completely out of date, are at least a fixed number for reference. Based on these data, since all the CPU prices are only separated by a few dollars on eBay, I definitely go for one of the 4-core, 8-thread options. Alright, those are the X3440 and X3450 CPUs from Intel's first generation. I hope you enjoyed this video and appreciate that you took the time to watch it. Please subscribe, like, or dislike, and leave a comment. Take care.